So you are following an online tutorial to complete a Python project. You have downloaded or typed up the code, and it requires a package. No problem. You know how to use the pip command. Pip install some package. But on your Linux system, you run into a cryptic error, externally managed environment. In this video, I'll explain why this happens and how to fix it. While I am working with VS Code, my intention is to provide a general guide that will help you regardless of your development environment. This is why I'll focus on pure terminal commands, but I will add some VS Code comments at the end of this video. So, why this happens? You'll see this error on the latest Debian-based systems such as Mint, Ubuntu, or Raspberry Pi OS, which I am using now. This issue stems from a long-standing conflict between Debian's apt package manager and Python's pip. Using both can cause software conflicts and even break your system. To address this, Debian introduced the externally managed environment. If you are installing a major library such as NumPy on your system, this isn't a problem. You just need to use the apt command with a Debian-specific package name. The command is sudo apt install python3 - followed by a standard package name, for example NumPy. The key difference here from a non-Debian system is the python3 prefix. Unfortunately, Debian's repository only includes a fraction of the packages available via pip. For example, I need the rpy-lcd package in my program, but it looks like I'm out of luck here. Of course, my rpy-lcd package here is just an example, and this video is applicable to any Python package installed traditionally using pip. Keep in mind, even if your package is in the Debian repository, packages there tend to be older versions. If you need the latest features, you may prefer a virtual environment anyway. Keep watching to learn how to set it up. While virtual setup is recommended, there is a workaround where you can still use pip. If you are willing to risk breaking your system, you can use pip install your package name with an option to break system packages. As long as you don't use sudo here, the package will install in your .local directory, affecting only your user account. This approach is generally safe and it works well for minor packages. The same break system packages option applies when uninstalling. Ultimately, using a virtual environment is recommended. If the package isn't available via apt, or you want to avoid system conflicts, create a virtual environment. Start with a system upgrade. Then ensure to have a full Python setup. Now create a virtual environment. The venv module, invoked with the -m option, sets up the environment in the .env directory in your home. Using a hidden directory will help you keep your account neat, and this name follows Python documentation standards. Virtual environment is essentially a copy of the Python subsystem, isolated to the user account. Once created, activate the environment using the following command, or using the period shorthand. Your command prompt will change, indicating the virtual environment is active. While the virtualized setup is active, the Python and pip commands will use the virtual environment's versions instead of the system ones. Now you will be able to install the missing package using the virtualized pip. To exit the virtual environment, use the deactivate command which will return you to a standard shell. Unlike Activate, no path is needed, just type deactivate and press enter. You can see now that with the virtualized subsystem deactivated, my Python and pip commands are back to the system-wide defaults. Your virtual environment must be active for any programs that use virtualized packages. Once this is taken care of, starting a Python program in a virtual environment is the same as in a plain shell. For example, using the Python command followed by the program name. By the way, on Debian now, using Python or Python 3 invokes the same Python 3 binary, as Python 2 is now deprecated. I still like to use the 3 suffix for clarity. If you use the / method to run your programs, you may need to adjust the shebang line at the top of your script. Let's have a look at my shebang. This shebang bypasses the virtual environment and uses the system's Python version, possibly leading to errors. Instead, use the env program to set it up. This shebang automatically selects the correct interpreter, whether in a virtual or standard environment. This syntax is the recommended approach for Python scripts on Linux today. If you use VS Code, it will not automatically detect your virtual environment. You will need to manually set up the Python interpreter, for example, by clicking the interpreter panel in the bottom right and providing a path to your virtualized Python. VS Code should detect the Python interpreter as virtual and activate it automatically, but in some cases, you may need to restart VS Code for all that to work. You can create virtual environments directly in VS Code or other popular IDEs as an alternative to terminal setup I just went through, but these tools are usually limited to a per-project environment, which I generally do not recommend. Per-project environments do provide the best isolation, preventing conflicts between project and system packages. However, they have drawbacks. Each environment takes up space. If you have many projects, storage use can balloon, becoming an issue especially on devices such as Raspberry Pi. With the notable exception of the Python executive itself, virtual environments don't update with system upgrades, potentially making them outdated or insecure. Keeping multiple environments updated requires recreating them and reinstalling packages, a hassle for many projects. For these reasons, I prefer a single shared virtual environment across projects, as I demonstrated in this video. I hope this guide will help you manage Python packages on your Debian-based system effectively. By using apt for core libraries and shared virtual environment for everything else, you get the best of both worlds, stability and flexibility. If you found this video useful, don't forget to like and subscribe. See you next time.